Previously, we have mentioned that the problem of the propositional logic is that there we do not automatically have access to the internal structure of a given statement. Therefore, to overcome this problem, we should split a sentence into more detailed components, thus recover our access to the internal structure. For example, let us look at the very simple English sentence, Mochi is lovely. There are two parts in this sentence. The first one is the subject, mochi, which serves as the term about which we have made the statement. The second one is the predicate, is lovely. This tells us what happens to that term. And we see that when we apply the predicate to this term, we got a complete English sentence. This is precisely how predicate logic works. More precisely speaking, from now on, we will usually assume that a set D, called the universe or the domain of discourse, is given. It contains all objects of our interest. Let us first introduce the concept of a term. There are basically two types of terms. The first one is called a constant, which refers to a specific fixed element in the domain. The second is called a variable, which plays a syntactic placeholder and is not referred to any specific element in D a priori. Yet, it can range through different elements therein. For example, I have two cats, namely Chui and Mochi. In this context, let us denote by D the set of my two cats. I will use a lowercase letter, say C, to represent Chui and M to represent Mochi. These two are called constants, as each of them refers to a specific cat. On the other hand, I can also introduce a letter, namely X. This X should simply be considered as a letter at this moment, and is not referred to any cat in the domain. In other words, this X is a variable. Now we typically use a capital letter, for example, P, to represent an n-ary predicate, which, when applied to n terms, becomes a formula, that is, a complete sentence. For instance, we can still use the previous setting and consider the predicate is lovely. This is a unary predicate and can be applied to a single term, either a constant or a variable. For instance, when applied to the constant C, it becomes a sentence, C is lovely, which means that Chui is lovely. Similarly, we can apply it to M, which becomes PM, and that reads M is lovely, which means Mochi is lovely. However, we can also apply it to X, and this time it becomes X is lovely. Although at this moment this letter is not referred to any particular cat, it doesn't change the fact that we have achieved a complete sentence. If you understand what's going on so far, then let us turn to a more mathematical example. This time, let us consider D to be the set of integers. First, let P be the predicate, is an even number. This is a unary predicate and should be applied to a single term. For instance, if we apply it to 4, then we achieve the sentence P4, which reads 4 is an even number. Similarly, let Q be the predicate, is divisible by. This is a binary predicate and should be applied to two terms. If we apply it to two variables, x and y, then we get the sentence x is divisible by y. Finally, we can consider the ternary predicate, the maximum of is greater than. And we can apply this ternary predicate to three terms, namely the variables x and y, as well as a constant 3. In this way, it becomes a sentence, the maximum of x and y is greater than 3. Alright, at this moment, I hope you have already realized that unlike in propositional logic, where each sentence is no longer decomposable, in predicate logic, each sentence is considered as the result of applying an n-ary predicate to n terms. This more detailed structure, especially with the introduction of variables, permits us to extend our study from a special case to general cases, from a single project to multiple projects, from a static point of view to a dynamical perspective. And together with the connectives and quantifiers, it will greatly improve our ability in dealing with more complicated deductions.